Alright, so in this video we're talking about the factor theorem. Now the factor theorem kind of builds off of our last video where we talked about the remainder theorem, and it also kind of builds off the idea of synthetic and long division. The nice thing about the factor theorem is that if it works, then we know that the remainder must be 0. Okay? So what happens here is if you divide one polynomial by some linear factor, x minus a, where a can be any number at all that you want, then the remainder has to be 0 if the factor theorem is true. And if the remainder is 0, then what that means is your divisor, x minus a, is a factor of your polynomial that was divided. That's great. And even more great is that the number a is a root of the equation f of x equals 0, where that f of x is the polynomial that got divided in the first place. Okay? So let's suppose that in our example we have x equals 3 is a root of 2x cubed minus 12x squared plus 22x minus 12. Well, to be a root is just another fancy name for x-intercept. So this is my f of x right here. This whole thing right here is my f of x. So what I want to do is I'm going to graph that. Okay? So I'm going to go to y equals and just type it in 2x cubed plus minus 12x squared plus 22x minus 12. And when I graph that, since I know that x equals 3 is a root, that means this graph should pass through the x-axis at x equals 3 because root and x-intercept are synonymous. Okay? So if I go through, I'm going to go to second calc, option 2, which is the same thing as called the zeros. My left bound, just need to find my cursor. There it is. It just needs to be somewhere on the left-hand side. My right bound needs to be somewhere on the right-hand side. And my guess, I'm looking at this root right here. And x equals 3. So graphically, we have verified that x equals 3 is a root of this polynomial because it has an x-intercept at positive 3. It also has some other x-intercepts or some other roots, but we're not worried about them for this problem. What we do want to do is use the factor theorem to also verify this. So remember, since it's a root, that means that when we plug in, the remainder has to be 0. So what we're going to do now, everywhere we see an x, we're going to plug in positive 3. If we end up with 0, then by the remainder theorem, whatever we end up with is the remainder. So we have 2 times 3 cubed minus 12 times 3 squared plus 22 times 3 minus 12. Again, by the remainder theorem, which is what we talked about in the previous video, whatever this is the remainder. Okay? So, we have 2 times 27 minus 12 times 9 plus 22 times 3, which is 66, minus 12. Okay, so what I'm going to do from here is just type this in my calculator, save a little bit of time, I hope. So 2 times 27 minus 12 times 9 plus 66 minus 12. And I ended up with 0. So that means the remainder is 0. So since the remainder is 0, then by the factor theorem, that means a equals 3 is x equals 3 is a root, which is exactly what we were trying to verify in this problem. And that's it for the factor theorem.